Advanced Chemistry, Chemistry 2. Today we're looking at mechanisms, the process of catalysts, in order to make chemical reactions take place. Now, the definition of mechanisms is there a process by which a reaction takes place. Now, there are what we call single mechanism reaction. We refer to these as elementary reactions, the simplest forms. They're single processes, not multiple steps. So, an example of a multi-step would be a first or one reactant or first order reaction. When we have these, we refer to these as unimolecular reactions. If we have two reactants and it's a second order reaction, we refer to it as a bimolecular reaction. And if it has three or more reactions, a third order, or just here we call it a termolecular. So those that we have, one reactant is unimolecular, two is bimolecular, three is termolecular. Alrighty. So let's get some examples. For the first reaction, we have a one reactant up here. Now, we don't worry about the coefficient. We only have one here. So this would be unimolecular. And this one, we have two reactants, even though their coefficients make more than two. And we call that bimolecular. Alrighty. Now, we said elementary reactions. We have are multi-step reactions. In other words, they take many steps. They're not elementary, they're not simple, they're very direct. An example of that reaction would be this one here. Iodate plus bisulfite gives you bisulfate plus iodide. Now, in a second reaction, that iodate plus hydrogen ion plus that iodide generates iodine plus water, and then we have starch in the reaction. That starch turns up blue-black. That iodine clock reaction that I showed you before, that's what we have right here. And we have what's referred to as a rate determining step. What is a rate determining step? The step that identifies the rate of reaction due to it being the slowest step. So of these three steps here, the iodate plus the bisulfite, the hydrogen ion plus the iodate plus the iodide, or the iodine plus the starch, which is my rate determining step. In this case, it's that second step. So that's when that reaction takes place. When that iodine is formed, the formation of the bisulfate, the formation of the blue-black concept are almost instantaneous. That slow step is that iodine formation. So that's referred to as the rate determining step when the reaction takes place. All right, so we do have factors that control the rate of reaction. There are four of them. First is temperature. Now, it's not always the case, but usually increasing temperature increases the reaction. So collision theory talked about before, more interactions, so they hit more often, more likely to take place. Second factor is particle size. Now, there's something called grain elevator fires. Have you ever heard of them before? Put silos in there, it gets hot. All of a sudden, that grain gets picked up because they're really small particles. They burst into flames. The smaller the particles, the more quickly the reaction takes place. Think about sugar. If you take a big cube of sugar, it takes harder to dissolve as opposed to fine granulated stuff. Third factor is concentration. Now, this makes total sense, and that's what we show in the iodine clock. As we increase the concentration, the reaction takes place. And the last factor is a catalyst. Now, just what exactly is a catalyst? A catalyst is defined as a substance that carries a reaction without being consumed, okay? It does that by lowering what's referred to as the energy of activation. What exactly, or how do we have these energy of activation? There are two types. We refer to as heterogeneous catalysts. They're the same phase, opposite phases, right? Heterogeneous, or homogeneous. They're the same phase of catalyst. They do this through a process of energy. Now, when we take reactants, almost always the energy state of the reactant is higher than the energy state of the product. But the reaction doesn't just happen on its own. It has to overcome a specific amount of reaction for the energy, rather, for the reaction to start. We refer to this as the E sub A. E sub A stands for the energy of activation. Energy of activation, which is defined as the energy needed for the reaction to proceed. That's called the E sub A, the energy of activation. So there's two different ways we can do this. The first is called a catalytic. What the actual reaction takes place here, what a catalyst does is it lowers that energy need for the reaction to proceed is energy activation. The catalyst lowers the energy of activation, makes it easier for that reaction to take place. Now, let's go back a little bit here, a few seconds. There we go. Obey the energy of activation. So there's two different ways we can do this. The first is called a catalytic complex. The definition of that, a substance that reacts to form a compound that will bring two other compounds together more rapidly. All right, the best way I can explain that to you is a matchmaker. Have you ever seen the Fiddler on the Roof? Matchmaker, matchmaker, make me a match. All right, here's what we have going on. We have two reactants. We have reactant A, reactant B. We want to bring them together, and they will come together, but it's a very, very, very slow process. And what we do with the catalytic complex is we have another catalyst, catalyst C. Catalyst C quickly reacts with A. We form a complex substance AB. We then have A, B, C all react together. Now, once those three are together, C falls out and A or B are together. That process by which they're put together is referred to a catalytic complex. Definition of catalytic complex, more specifically, a short-lived intermediate compound used to bring two reactants together. So it reacts in the compound to bring compounds more rapidly together. All right, the second way we can do a catalyst is through a substrate. Substrate provides a substance in which reaction takes place more rapidly. This is platinum. Platinum is often used as a substrate, as a catalyst to make reactions take place. Another way we can look at it is through enzymes. Now, if you know anything about biology, enzymes help make proteins. This is the way they work. So it's a naturally occurring catalyst in protein formation. So there's my enzyme. Amino acids come along and they combine up with that enzyme. And we get 2 and get 3. We can actually have hundreds, if not thousands. Once they all form up, the enzyme peels off and we have the completed. This makes it a substrate. Okay? So that's the structure we have. That's the way this forms up a substrate. It's a natural occurring one. Hopefully that's not too bad. Take care. God bless. Bye.